Hi, I'm Spencer Bingham, and I use he, him pronouns, and I'm currently working on my PhD in material science and engineering. And today I'm going to talk to all of you about my work in protecting wild rice in Minnesota and how we use waste from the mining industry to immobilize sulfate, which is a threat to Manoomin or wild rice. I wanted to start with saying that rocks aren't boring or dumb. Even though they're just rocks and they don't seem like they do much, rocks are very important and active in our environments. In fact, we need rocks and minerals to make a lot of the things that we use every day. Certain kinds of rocks contain the materials we use for buildings, cars, technology, and more. And because they're so useful, we work hard to get these useful rocks and minerals out from under the Earth's surface to above it, where we can get to these materials. But as much as these rocks are helpful, they can also hurt us. When we bring these rocks and minerals up to the surface of the Earth, they can react with air and water to form sulfate. Now, sulfate is a pretty common chemical that's found all over the place and it isn't considered particularly dangerous. It just flows around with the rainwater and ends up in Minnesota's many, many lakes, streams, and rivers. Now, once the sulfate is in certain lakes, bacteria at the bottom of the lake eat up the sulfate to make a related chemical called sulfide. This is the same chemical that gives rotten eggs that stinky smell. Again, this normally isn't very dangerous. In Minnesota, though, we have something pretty special. Minnesota is filled with wild rice lakes, where wild rice, or Manoomin, grows. Manoomin is a very special plant that many communities in Minnesota want to keep safe because of its cultural significance and the tasty rice that it makes. When sulfide touches the Manoomin, though, the plant gets hurt. Here you can see on the left a picture of healthy Manoomin roots, but after growing where there was sulfate and sulfide, the roots turned black and the plant was really damaged. And that's what we're trying to prevent from happening. A bunch of scientists and engineers that I'm a part of are working to mimic what happens in these wild rice lakes to stop the sulfate that starts all this trouble in its tracks. What we do is we pump the sulfate contaminated water into a tank filled with those same kinds of bacteria from the lake. They eat up the sulfate and make sulfide. Then instead of attacking the wild rice roots, we have the sulfide react with leftover rocks from mining. These rocks were the leftover ones that weren't very useful in getting special metals and elements, but they're very good at reacting with sulfide. They make a final sulfur-containing product, and then we can say that the sulfate has been immobilized and it can't move around our lakes, streams, and rivers because it's stuck in the form of a rock. And then the Manoomin is safe and happy in its sulfate-free water. My work specifically looks at this one kind of mineral called siderite, or iron carbonate. And I look at how this specific waste mineral reacts with sulfide and what I can do to help siderite remove sulfide as best as possible. But that's just my work, and there are so many people working together to protect Manoomin and keep it safe. And these are just a few people I work with on this project. Now, I hope all of you learned something, and I hope that you can enjoy the rest of your day. Happy Pride.